Lesson 10 is going to be converting moles to liters of gas. So we're going to be talking about Avogadro's gas law. We're going to be looking at ratios again, and then we're going to be setting up some practice problems. So Avogadro found that if any gases were held at the same temperature, pressure, and volume, then those gases would contain the same number of particles. He states that 1 mole of gas is equal to 22.4 liters of that gas at STP. So it could be oxygen, or it could be monatomic neon. It could be a poisonous gas. It could be a beneficial gas like an asthma inhaler. It could be any type of gas. If you have 1 mole of that gas, it's 22.4 liters. If gases are held at STP, which again is table A, which means standard temperature and pressure, and contains a volume of 22.4 liters, then we know we have 1 mole of that gas. It is a very simple conversion to understand. This is only for gases. You would not use this formula for liquids or for solids.
The reason why is because gases are compressible. Solids and liquids are not.
So again, looking at our number line, if we say that 1 mole is equal to 22.4 liters, which is our standard, let's say we were going down. If we are going from 1 to a half a mole, we could say that we're going half of the amount of liters that we have. So if we set up a formula, our standard, which is 1 over 22.4 liters, is equal to 0.5 over x. When you cross multiply, you'll notice that we get 11.2 liters. If it's less than 1 mole, you should have less than 22.4 liters. In our second example, let's say we want to double the amount. So if we double, going from 1 mole to 2 moles, then we can predict that we will have more liters than what we started with. So 22.4 times 2 tells us that if we double up the moles, we should get double the amount of volume.
Here's a scenario where we're given the liters of gas and trying to find the moles. If we have less than 22.4 liters, for instance 5.6 liters, we're going to anticipate less than 1 mole. You set up a proportion with the 1 mole is equivalent to 22.4 liters, and you cross multiply and you find that 5.6 liters is equivalent to 0.25 moles of whatever gas we're referring to. Then if we have more than 22.4 liters, like 39.2, we set up this proportion again, 1 over 22.4 liters. Now we're going to cross multiply and divide, and we're going to find that 39.2 liters is equivalent to 1.75 moles of whatever gas we're referring to at STP.
So we're going to use the amount of moles present in the formulas, which are the coefficients, to determine how many liters of gas we have of each species.
Assume that all these gases are held at STP.
So in our first example, we have 2 moles of oxygen. So we know that 1 mole is equal to 22.4 liters. So 2 moles is double that, so we get 44.8 liters of oxygen. In our second example, we know that 1 mole is equal to 22.4 liters, but we have 3 moles, so we're tripling that amount, and we're getting 67.2 liters. In our third example, we're going to half a mole. So we're taking 22.4 and multiplying it by 0.5, giving us 11.2 liters. And finally, again, we're taking less than a mole, and we are taking 0.75 moles of water times 22.4 liters from our standard, and we will get 16.8 liters of water vapor.
So here's a scenario where we're given liters and we're asked to find moles. Remember, assume that all these gases are held at STP. So we have 179.2 liters of ammonia. We know that 1 mole is equivalent to 22.4 liters. We're going to create a proportion and find that X is equal to 8 moles. Next, we have 2.24 liters of water. So remember, 1 mole of any gas at STP is equivalent to 22.4 liters. We're going to set up a proportion with the 2.24 liters and find that X is equal to 0.1 moles. Again, try to assume if you're going to have more or less than the original 1 mole. Next, we have 17.92 liters, less than 22.4 liters in 1 mole. So when we set this up and create our proportion, we should anticipate an answer of less than 1 mole. So we get 0.8 moles. Lastly, we have 134.4 liters of methane. 1 mole is always equivalent to 22.4 liters of that gas at STP. Set up a proportion, should come out greater than 1 mole, which it does, and it comes out to be 6 moles. When gases are not held at STP, there's a different formula that we will talk about in the next unit.
So Avogadro also has this thing called his hypothesis, which states that any two samples of gas at the same temperature, pressure, and volume have the same number of particles. This is what we talked about in the beginning of the video. So for example, which sample would occupy the same volume as a 2.5 molar sample of oxygen gas at STP? If you look at your answer choices, if you have the same amount of moles, you have the same volume. The only answer that has the same amount of moles is D. 2.5 moles of methane has the same volume of 2.5 moles of oxygen gas. Another example would be, which sample would occupy the same volume as the 2.5 mole of the oxygen gas? But now we're talking about volume in all of our answers instead of moles. So you would have to convert. What is 2.5 moles in liters? So 2.5 times 22.4, you're going to get an answer which is 56. So it would be answer C. 56 liters of fluorine gas is the same as 2.5 moles of oxygen gas.
Notice that in both scenarios, they specifically say that the gases are held at STP. This is very important because you need the same three conditions of volume, temperature, and pressure.